Now, coming to the point of your capabilities of GIS, how do you input the data, how do you work with the data? As I was just telling you, the first point is your data capture or inputting the data in a GIS environment. How do you do that? Inputting of data by say digitizing, scanning or direct coordinate entry. So, we will see one after the other, you will get a better idea when I just show you the slides about how it is, of course, how digitization is a process, but still how we can work with digitization. Then scanning, an important thing of hard copy making into a soft copy in the form of say it is again non-editable, we will see the details later. And finally, we also have a direct coordinate entry, that is getting the XY from the field and then inputting into a GIS. Then we say how do you edit the data, because once I start digitizing, anybody for that matter will be committing errors. So, you have to edit the data in a GIS environment to see that the errors are removed or corrected, and finally you can also add features. So, editing is also a facility which is there. Next thing is important is here labeling the features. As I was telling you, all features could be point, line, data. So, they can all be identified and they can be named and coded together. So, hence we say that GIS capability or a data capture unit in a GIS software should be capable of inputting the data, editing the data and labeling the data, so that I will be in a position to use the data effectively. Now, let us see in detail what are the various inputs where from I am supposed to get my GIS data, because as I just told you, it is just a software cannot do or cannot take its own decision, isn't it? You will have to instruct the software. Now, let me start from the basic. How do you get the data, where from you get the data? So, various inputs into GIS. How do you get the data, where from you get the data? First is satellite data. When I say satellite data, the data which actually we obtain is say from satellites. So, these satellites are capable of giving you satellite images, and then we will be using the satellite data for a specific purpose, specific application. All these things we can see in later classes. In the sense when I am using, just let me tell you an example. When I am talking about say an earth resource, namely oil investigation. When I want to work on oil investigation, I need not work with a large scale data, isn't it? I will have to use small scale data, because I will have to see large areas. So, in the context of such an application, I use small scale data covering large areas, wherein when I am trying to work on infrastructure mapping, or when I am trying to work on your say land parcel mapping, then I will have to go for a large scale which covers small area. So, do not get confused with large scale and small scale. So, small scale is nothing but we represent large areas in a smaller sheet of paper, whereas large scale we represent small area in a large area, say map. Hence, you should know what is the difference between large scale and small scale. That will form an important source or decision making for you to go for which satellite and which data have to be used. So, satellite forms the most important input into GIS environment, especially the present day satellites are capable of going for a resolution of 1 meter. You should be aware of what is the resolution. A resolution of 1 meter is that which is the latest satellites. In fact, we also have satellites which is they talk about 50 centimeters, but normally they are resampled into 1 meter because of various security reasons, and the satellites are providing you, or the service providers are giving you satellite data which is has a huge resolution. Well, when it comes to you application like water resources, or your, for example, I was just saying oil mineral investigation, in such cases you need not necessarily use a large scale map, you will have to use a small scale map. So, in such cases we go for a satellite data which has got a smaller resolution in the sense 80 meters, 30 meters. When you talk about infrastructure mapping, we use satellite data which has got large resolution in the terms of say 1 meter, 2 meter, etc. So, the first and the foremost input what we obtain from or what is required for GIS is your obtained from say satellite. So, that is the first thing. Now, we also have, of course, when I talk about satellite data, I will also have to talk about aerial photograph data. So, aerial photo is again another kind of input which we normally input into GIS environment. We say aerial photographs are inordinately expensive in nature. Depending upon certain applications, depending upon trying to obtain say a 3-dimensional detail about a particular terrain, then we use say your aerial photographs. Otherwise, aerial photographs are, as I told you, expensive. 3-dimensional data study is possible now with satellite data, even the present day we can also use satellite data, but still contour map making for going for a third dimensional detail, we have to use aerial photograph. So, this also forms an integral part of your GIS. So, data from satellite and data from aerial photographs are the two important inputs into a GIS environment. Then we can also talk about, say, topographic maps. Let me just show you how a satellite data appears. You must have seen a satellite data. In fact, in the olden days, it was very difficult for one to get a satellite or a view a satellite data. In fact, we used to find difficult to even look at the satellite data because of various reasons. But now, with the advent of your Google, you find that the satellite data is available just like that. Every individual, every child is also knowing what a Google map or a Google Earth is all about. So, we get the satellite data from Google as a free of cost, but anyhow, if you are interested for application, you will have to go for buying a satellite data which will be of high quality. So, a satellite data, I was just showing you that what a satellite data is there. As you just see that, I was just telling you about one aspect, namely your satellite data, wherein which we have it is a satellite image. You do not call it as a data. I mean, it is not a raster data, it is more of an image, satellite image. In the sense, when you just try to enlarge it, it becomes pixelated in nature. You can see on the right side of that, you find the pixels, that is a cell size. All these things are all your, depending upon the resolution of the satellite data, you get that. So, the most important thing is that in satellite data, we use raster image. In GIS, we use raster data. So, that is a major difference between the two. Well, now coming to the next point, preparation of a thematic map. I just told you about that. Satellite data itself cannot be used directly in a GIS environment. Of course, in some applications we do use satellite data, but that is a base for generating a thematic map. As you can see from the thematic map, we say that the thematic maps are nothing but represent a specific theme. In this context, it is a soil map. Just to give an idea of what exact how does a map is prepared. So, we have a soil map which is prepared from a satellite data, and that also these thematic maps also can be prepared from aerial photographs, irrespective of whether it is going to be satellite or your aerial photographs. We can prepare a thematic map, and that thematic map is nowadays, of course, we are also using satellites, your satellite data incorporated into GIS environment and digitized directly and prepare a thematic map. Previously or in olden days, we had maps prepared from our forefathers. Lot of maps are there. All these things will be of different scales. In fact, the GIS is a very good tool to integrate different maps on different scales into one under one environment rather. So, in fact, we can use that. Of course, nowadays, as I was just telling you, we can also use the satellite data, aerial photograph data directly in a GIS environment and then start digitizing and work on that. Otherwise, we have to scan the data. We will see that detail later. The next point is a topographic map. As you can just see here, a topographic map, as all of you know, that a map which has got a topographic detail, nothing but a third dimensional detail. So, this is what is a topographic map, a very important input in a GIS environment. In fact, we all call that as a Bible for our study. In fact, for all applications, we use this topographic map very effectively. Of course, incidentally, the topographic maps are of only small scale, 50,000 and 25,000 scale, and in some cases they also have 5,000 scale topographic map, but it will give a huge information as far as the data is concerned for a GIS environment rather. Now, the next one is your FMB sketch. An FMB sketch, as all you know, a sketch which is drawn by surveyors in the field. In fact, from your point of view, from an architecture point of view, you have to use FMB sketches in various, you must have rather used in your study over a period of time. Now, when you say or talk about FMB sketches, they are all basically of non-earth coordinate system. So, when I am using FMB sketch, that has to have very much all details for me to build an FMB sketch into a GIS environment. Otherwise, you will only have an option left by simply scanning that and digitizing the data. Simply scanning and digitizing data will not give you good results. Hence, we have to use an FMB sketch effectively. If that is the case, we will have to have lot of details as far as the FMB sketch is concerned. We normally have a ladder data. We also have to have the various directions and also the degree or the values in terms of degrees, minutes and seconds. In older data, we used to have only your degrees and minutes, seconds are not there, because that is the reason we are finding it difficult present generation, we are finding it difficult to use the older FMB sketches. An updated FMB sketch will contain all these details, and then we will be in a position to use that effectively. Then coming to the observed points. points which I just told you in the beginning itself. So, points are the data what we obtain from, say, from the ground. For example, when I have a particular or a specific detail about any particular application, let me talk about a well location in a specific application. I try to get the latitude and the longitude of that particular well, and you can see here the longitude data, the latitude data, a given area, and these are all observed points, and we observe it with the help of various techniques. Now, coming back to that particular aspect, getting data in the form of point or coordinates in the field, that is an important thing. Of course, now all of you know that GPS is a very useful tool, and we use GPS to obtain a position of a specific point on the Earth's surface. This forms an integral part of your GIS present day. In fact, we can also use direct data directly from your DGPS, differential GPS, and then incorporate into a GIS environment and then manipulate the data in a GIS environment. Or we can get the XY detail about a particular phenomena, namely well data or rain gauge station or any other thing I was just telling you of the electric pole or any other detail, and that can be incorporated in a GIS environment directly or as a point data. So, this is what we normally use for in the case of your GIS and observation of points. We observe the data in the field, take it into a GIS environment. So, that is a one point. Then we talk about the map data, how we are going to input the data into a GIS environment. I just telling you, we say that data can be input through digitizer board. In fact, this is an obsolete thing, but still a very powerful one till let us say, for example, even for 5-6 years ago also they were using it. Of late people are not using digitizer board, they are only trying to use the scanners. So, a scanner is used, the hard copies are scanned and then they are digitized or convert into a soft copy. So, when I scan the data what I obtain is in the form of a hard copy, in soft copy, but that cannot be edited. Hence, we have to see or make the system to understand what is present in each of the scanned images. Just imaging or scanning is nothing but taking a photograph, like something like similar to taking of a photograph. You cannot edit it unless otherwise you go for a specific software. So, we have the photo editors. So, similarly in the case of a scanner, it's something like taking a Xerox of it. You cannot do anything with that, it will be just representing. Instead of having it in the hand, you are going to have it in the system, that is all. So, that is the role of a scanner. A scanner will help you to scan the drawings, maps, and then bring it into a GIS environment. So, when I am using a scanner, I will try to convert that hard copy into soft copy, but not editable. So, that is a basic thing, please underline that. So, as you can see here, scanners, as of course, these are all simple scanners. You can use these scanners, of course, different types of models are there, you can use scanners, obtain the data. I am just telling you about how satellite data can be converted into thematic maps. These thematic maps can be converted into JPG or your TIFF or whatever is the format you require. Almost all the formats are accepted by GIS software. In fact, I will show you at a later stage various formats accepted by GIS software. Now, this particular data what we have just seen is that from a scanner we use the Tamil Nadu map, just an example. It has no significance, it could be anything for that matter. A Tamil Nadu map is shown here, which has got about n number of districts here, and it is also showing the latitude and the longitude in the given area. So, the total area, as you see on the left side, I have just mentioned x and y is in feet or meters. So, this is what is the major difference between a drawing and a map. In the case of your drawing, we say that a map once scanned or a sheet of paper once scanned will be shown only as a feet or meter, it will not be referred to any earth coordinate system. Hence, I am going to now use a specific software, a simple software, we call it as map info. So, we have so many different types of software. A simple software, as just telling you in the beginning itself, anything when we intend or when we want to convert the data, a simplest software is your map info, because other software also can be used. A map info software is being used here to make the system to understand that the scanned image of Tamil Nadu is not just a image, it is a map. Hence, converting or making it in from non-earth coordinate system to earth coordinate system. So, as you can just see that, let me just tell you in detail how to do that. A simple procedure can be adopted. Here, when I come to these works, I decide I have various things. I select a a table file or anything for that matter. So, let me say I image I get the data which is in again feet. I want to convert that into an earth coordinate system. Here I select I ask the system what is that, normally it will give an option. I choose latitude longitude because my basic data is in latitude longitude. So, I am also going to use latitude longitude rather than your UTM coordinate system. I use the latitude longitude, I choose the rather latitude longitude system, and then you can see that there are host of systems, coordinate systems which are available in almost all the GIS software. Many of them are there, in fact it will be just going, many are there. So, you can see here in the latitude longitude system we also have for different countries. We are going to choose latitude longitude for India, Bangladesh, that is one, or your India, Indian for Thailand and Vietnam. So, we are supposed to use here Indian for Bangladesh, India and Nepal. So, this particular option we are going to choose, click on that. Again we have an option saying that whether it is going to be India Everest or India WGS 84. So, you see the importance. So, we normally, because now most of the times the data which is provided by Government of India in different forms has got a polyconic projectron system, and they use a coordinate system, namely your India Everest or India WGS 84, World Geodetic Survey 84 system. So, you can choose one of them. Let me say, let me use your Everest system. Now, option it gives, and then you can see from the drawing itself some points. I will explain you what exactly is that. You can see from the various points which I have chosen on the drawing or scanned image. Now, I know that from the drawing what is the latitude and the longitude. So, from here as you see the red points which are indicative here, you should know which is which. So, let me take for example this particular point which is indicating your 77 degrees and 11.25. So, 77 degrees on the x coordinate and 11.25 in the y coordinate. Please do not get confused with your x coordinate and y coordinate, that it has got a very important significance. Most of the people get confused. X and y, x coordinate always represent your longitude, y coordinate represent your latitude. So, this you have to bear in mind. Now, coming back to the registration of your non-earth coordinate data into a earth coordinate system. So, I will have to prick a particular point on the drawing indicating or finding its xy, because it is already known to me the xy of this particular point because of the drawing which I have scanned has got latitude longitude details on that. I take the intersection of the latitude longitude, prick and explain that, make the system to understand this first point is your say 77 degrees and 11.25 degrees, and so on and so forth. I just move along this particular point anywhere, because of course there is no significance in showing you here. This is the second point and there is a third or the fourth maybe somewhere, and only a few points are shown here, and we have n number of points. Once it is over, then it will ask you, or it once you say it is okay, I am satisfied with that, it will show you the error in pixels, indicating that the position of the object has errored only by 3 pixels. 3 pixels is only 90 meters in the scale of say 250,000, literally error free. You can go up to 10 pixels, it all depends on the software and the various applications. So, if it is going to be infrastructure map, you cannot take the risk, you will have to go for a very high accurate position. Whereas, in case of your earth coordinate, like in the entire Tamil Nadu, we are using on a very small large scale 1:1 million or 1:500,000, there is no problem in your error here. So, GIS will help you to or indicate you what is your error level. So, once that is there, you can just decide, and once you are satisfied, give OK. Now, you see here that particular thing what I have scanned is now converted into a GIS map, and the data is in latitude and longitude. So, the first thing achieving is that I have converted, I have made the system to understand that the drawing whatever I have scanned is now a earth coordinate system or refer to a specific coordinate system with respect to the globe, and that is got that is now a data which can be, or which is rather ready for us to be used. So, what is the purpose of this particular map? What am I going to do with that? Of course, this is only for example I have just shown you here. In later stages we can see various types of maps and drawings and things like that. Now, coming back to my drawing here, I just try to display the drawing on the software, and the software will be just giving an option. I just showing you about the error option, and I was just thinking that whether can we improve the error if I am not satisfied. What I am going to do now is that I am going to adjust the image in such a way I will not get even the 3% 3 pixel error. So, I say raster image, I select the adjust image style, and you can see here the error is literally removed. Now it's become 0 1 0 1. What I have done is that I have enlarged the image or zoomed the image a little more and then made it much more accurate, and now you see the error is literally removed. So, this is one method of improving the error and then displaying the data. Previously it was 3 pixel error, now it is only 1 pixel error. So, this is an important aspect you have to bear in mind. So, it again depends on your application and the patience with which you have to do. You have to be very patient in registering the data. So, data registration forms the most important thing if it is going to be a, say, something like a hard copy which is converted. If it is going to be a satellite data are not going to be used directly in your GIS environment. It is also to be rectified, that we will see at a later stage. So, we will have to use the data, register the data in such a way the error is almost 0 or 1 pixel error. So, as far as the raster image is concerned, we are getting a 1 pixel error or 0 pixel error. So, that is what is there in this context. Now, coming back to the map now. As I was telling you, the map is now displayed on the monitor and it shows the latitude, longitude, and now I am going to convert the data. As you can just see here, of course, I have not shown you the method of conversion, that is little tedious, that we will see at a later stage later probably. Now, how the data is converted, here you can see here I have digitized along this line entire object. So, as you just go through along this, use a tool. All of you must be aware of a tool where you can convert the data using your, normally you must be aware of your CAD or your AutoCAD, where in which you use the tool to digitize the data, convert the data from raster to vector. We call it as R to V, raster data to vector, raster image to rather vector data. So, this is how it is converted, and you can find that the entire districts are digitized here in various forms. So, you can see here various districts are there, n number of districts are there. On the right side, very important, I have the attribute information. So, the attribute information is normally fed into the system using ordinary data, which can be linked also at a later stage. I will tell you how to link the data. Now, the attribute information is now fed by using your keyboard. So, now we know that particular district is known to us. We can give the name to that, we can give the area, we can tell you the sex ratio in that, we can talk about the literacy rate, whatever you want to know about the particular district, the health characteristics, general population, the female, the male, whatever you want, the child, whatever detail you want to know or what you know about particular district, it can be incorporated. Please bear in mind, there is no limit to the number of fields. We call every detail as a field. There is no limit to the field. You can have any number of fields. There are no restrictions as in other cases like Excel and things like that. You can use any number of fields and then bring it into a GIS environment. So, once we digitize the data, the system will understand, yes, this particular land parcel is nothing but your particular district. Of course, in this context it is Tiruvallur district, it can be anything, any district anywhere in the country. So, now we also get the data into the system, we also have the details about that particular district. So, coming back to the drawing here, so we can say that yes, monotony, to break the monotony we can use something like this. This particular map is converted from raster to vector and it contains about say 26 or 27 polygons, we call it, all these things are called as polygons, they are all area in nature, and we can get the area also directly from this application software. Then we can give the details here. Once you have that, it has got some monotony. So, it is all in yellow color. So, you have an option in GIS, showed that in a different color. So, you can see that each district is represented in different colors and each of them are also shown here, but it may not be possible for you to understand that which is which, because it will be difficult for you to correlate that. So, in that context we say, we ask the system to simply label the data. You should I think you will be remembering what I told you then earlier, that how to get the data. When you are using in a GIS environment, you can also, you need not necessarily input the data, you can also label the data. So, by labeling the data, you will be in a position to know which is which. So, that is a very important input, isn't it? Do you agree with me? So, a monotonous appearance of the map is changed and I am showing the various districts in different colors. I am also labeling the districts in such a way I understand very easily. In fact, we also have a very simple tool called as info tool, which I shown you earlier. This is what is your info tool. Info tool will also help me to know the details about an object. So, when I just use this info tool, I click here, by clicking I get the information about that particular object here. This object here referred to is nothing but your district boundary. So, we have the information about this particular district. So, mere having a details about that will not help you, isn't it? You will have to do something different. So, ultimate aim is that convert the data into a system or a data which is understood by the computers, which is also should be useful to us. For example, let me talk about a specific thing, a simple example how to use the data. Now, once I have typed the data, I have the data in GIS form, which has got reference to a earth coordinate system, namely latitude, longitude. I also have attribute data, we also called as non-spatial data. So, data which has got reference to space is spatial data, namely the map part, whereas details about that particular spatial object is called as non-spatial data or aspatial, aspatial data. So, this is what you normally call it as. Well, so coming back to that, once I have the data, what am I going to do with that? There is no point in just having the data, isn't it? I will have to do something with the data. So, in this context, I am going to use the data and then try to find out what is the variation in the population with respect to male or female, whichever is that you want to know. So, let me see that when I look at the data, I have the population, then the literacy rate, the migrant population, the tribals in that area, and what is the total area and the various districts here. So, now taking that into consideration, I will take one of them, population. I can also have a breakup male and female. I can create a model here, a simple 3-dimensional model. How set data is represented here. You can see here how the data is shown here in 3 dimension. So, this is your Coimbatore district, because it is a huge district and you also have a lot of many more people are living there, population is more here. Kanyakumari, a small district with less population, hence it is shown it is a slightly depressed manner. So, we have the advantage of using these GIS data, a simple analysis, not a very complicated one, make you to understand how we can analyze the data in GIS. Bear in mind, this is what actually happens as far as GIS is concerned. So, we have to understand how data is converted from raster to vector R to V. So, that is a basic thing. Once you incorporate the data in GIS, this is where we come into the picture. Any application scientist or an engineer comes into play and he will be using the data, he will be working the data according to his requirement. In fact, you do not require highly qualified or skilled persons to convert the data. That does not mean that you should go for a low skilled persons. A moderately skilled staff members or personnel are more than sufficient for you to convert the data and first bring the data into a GIS environment. So, let us see now how the data can be worked or how to work with GIS data. Now, here the basic thing what you should remember is that in GIS the most important thing is that data can be shown of a given particular terrain. This is a particular terrain, you have a small area and that area is represented in a sheet of paper or a map, and what is the most important thing or application is that it is shown in different layers such as land use, streets, districts, that is administrative units, and land parcels. So, please bear in mind, GIS is such an important tool wherein which all the aspects are layers like land use, streets, districts and parcels are otherwise called as layers or coverages. So, this is what is the important aspect in GIS. A model here, the real world model is here, you can see here, that is converted into a GIS environment. In a GIS environment, it is shown as different layers. So, advantage is that though streets, you can see here streets, you can see the land parcels, you can see the trees here, you can see the district boundary surrounding, all these things are in one single layer, but now GIS helps you to differentiate them and then put them into different units. The advantage is that when I want to work with streets, when I have an application pertaining to streets, that is when as a planner, when I want to work with GIS in using street data, what is that we will be doing it? As a planner, we want to know what is the existing streets, what is the width of the street, where all you have the streets, where of course it could be roads, could be lanes, by lanes. For example, when I want to or when I intend to widen a particular street, I will have to go to the field, collect the data, but GIS will help you or will not force you to go to the field. If I have proper GIS data, as all of you know, garbage in, garbage out, if my input was proper, If the data is properly brought into a GIS environment, I will have a data that will be readily useful for me in any application. Thank you.